What's going on, kids? It's Mr. Bullens here. Just want to start off and say that I really do miss all of you guys, and I'm really looking forward to when I get back to school. Um, I know that we are preparing for the test. Obviously, that test is not going to be this week. The odds of me coming back this week are pretty low, and obviously, I want to be there to have one good review day to make sure that we're all ready for the test. I am going to kind of move forward. I'm also going to be doing some review things as well as we move forward. And I know a lot of people have been asking about your books. If you happen to think that you are finished with your book, you are more than welcome to shoot me a message in class, Google Classroom, and I can look at your book and go ahead and start grading some of those. It'd be awesome to come back and have some of them graded. But if you happen to be one of the people that are still working on your book and you need a little bit more time, there will be some time in class today that you'll be working on that. And we will move forward with that. Obviously, I'll give some people a little bit more time on Friday as well to work on their books. And hopefully, if you're using your class time effectively, you're getting that done. No one should be super far behind on those books because we were chugging through those pretty good when I was there during the week and looking at people's books. There were a few people that were a little behind. There were some people that were behind that had been out of class, and I understand that. But let's make sure that we're using our time effectively when we are in class over these next couple of days. So we're going to keep talking about wind and weather. This is going to be the things that will be on the next test. Do not stress. That will obviously be the very beginning of fourth quarter, and we'll talk a little bit more about that when I get back. But we can't wait on this as well, so we need to go ahead and start talking about some of these things. So wind and weather. I know that we spent a very good amount of time in the class talking about latitude and longitude. Now, remember, I don't want to say that these lines of longitude are not important. They are very important. But where you are on the line of longitude does not matter nearly as much as where you are on these lines of latitude. Because remember, the closer we are to this area, the equator, the warmer we are, the further away we get north or south on the equator tells us how much cooler we are going to be. And that's going to come into play pretty huge here when we start talking about wind and why wind forms and how wind can move from an area of high pressure to an area of low pressure. And a lot of it has to do with the uneven heating of the Earth's surface. And it does take a general understanding of you're warmer at the equator than you are at the poles to start understanding some of these different winds, like the doldrums, the trade winds, the easterlies, and those extremely important prevailing westerlies that we will talk about in the upcoming slides. We remember that we talked about this in class, that this equator divides us into a northern hemisphere and a southern hemisphere. And due to the tilt of the Earth, we experience opposite seasons. So if you're in the northern hemisphere, which is where we live, we are about right. I don't know if you can see I don't know if you probably just see a big yellow circle, but I can see a pointer right around in here somewhere. We're looking at America, but North Carolina's right there. We're in winter. So if that means down here in the southern hemisphere, they are experiencing summer. So they experience the opposite of us. Now we're obviously getting ready to move into spring. So then they would have the opposite of us as well. They'd be going into fall. And here's a little bit more. This slide's more about latitude, but we took notes on this in class. Just kind of wanted to refresh. You are welcome to go back and watch these videos as needed. I'll put the codes in Google Classroom for you today in case you need to go back and take some notes or slow down. Air temperature. Now, again, as I mentioned in class, I didn't spend a lot of time on this slide because this goes back to the things that we talked about, how every single topic we teach is a building block for the next. And that includes moving forward in the next grades. You should understand from when we talked about states of matter that even though they're both still air, the molecules in this cold air are going to be closer than the molecules in this hot air. And that is because the ones in the hot air have more energy and they're moving around faster. Probably one of my absolute favorite things this year in teaching. There is one young lady, I will not call her name out, I will tell her this privately, but every single time I talk about this, I see her moving her hands around the way that I do when I'm explaining this, because I'm simulating the molecules. And it does make me feel pretty good to know that somebody really connected with that. It's pretty awesome. She probably knows who she is. And we'll talk about that maybe more when we get back to class. And I'll let her grandma know how proud of her I am as well. But again, cold air is more dense because the molecules are closer. Cold air is a little heavier. Therefore, that's why when we think back to those convection cells that cold air sinks, hot air has more energy. It is less dense. Because of that, the molecules are spread farther out and the hot air rises. We saw that with water. We saw the cold water sinking. We saw the hot water rising in our convection experiment in class. And this is an extremely important concept to hold on to as we move forward through the rest of this unit. I'm not going to spend a lot of time on humidity. I do think it's important that we know what it is. It is important that you know that you use a hygrometer to measure humidity, but humidity is how much moisture is in the air. So obviously, the hotter it is outside, the more evaporation you have going on, the higher the humidity is going to be. That's why in the summer times you have those days where you can just stand outside and sweat. And you typically don't have days like that in the fall and in the winter because there's not as much evaporation going on. But again, this is just a vocabulary word I need you to know. It's not something that I'm going to spend a lot of time on, but you will see this term pop up in questions. You will see this term pop up as an answer choice about things, and it may not necessarily be the answer, but I certainly don't want you to see a word and think, well, I don't know what that word is. That has to be the answer. That's why we cover some of these words as well. So we just talked about air and how cold air cold air sinks and hot air rises when we were talking about air temperature. This brings us to, like I said, probably some of the easier vocabulary words from this past packet, and that is updraft and downdraft. And all you have to do is remember your convection cell. All this is a giant convection cell. And if you can understand this, when I get to sea breeze and land breeze, you already know the answer. Because if there is an area, let's say this is the sand during the day, the hot air rises. The cool air sinking over the ocean, the wind moves from the ocean. Change this to the nighttime, this would now become the ocean and this would be the land. It's very easy to understand that if you could just remember that. But remember, an updraft is an upward movement of hot air, rising hot air. A downdraft is a downward moving cool air because cool air sinks. They're very easy, and it really does connect to that convection cell that we talked about. And I think it's extremely important for us to understand that. Now, again, we talk about why in the middle of this, why is there wind at all? You have uneven heating, number one, and number two, you have a difference in pressure. Notice over here you have high pressure, over here you have low pressure. If I blow a balloon up to its maximum capacity, we all know that the pressure on the inside of that balloon is greater than on the outside. And when I let go of the end of the balloon, no one expects air to go into the balloon. We expect air to come out because the air is moving from higher pressure to lower pressure, and that's the way that wind is created. Here we are, wind, the horizontal movement of air. Air moves from high pressure to low pressure areas. That's extremely important to understand. Now, that's one way they're going to ask you is how does wind move? And the answer is from high pressure to low pressure. One of the reasons why that happens is the unequal heating of the Earth's surface. I can guarantee you they're going to see that. Those folks that love that brackish water and terms like that so much, like they're really going to talk to you like on the test. And we've seen some of those words pop up, like estuary, decomposers, brackish water, unequal heating of the Earth's surface. They love this one as well. And they love to put that on there very often. And they also like to put, from high pressure to a low pressure. So wind is the horizontal movement of air. How does wind occur? It happens because of the unequal heating of the Earth's surface, which causes areas of high pressure and low pressure to form. And then the air is going to move from the higher pressure to the lower pressure. Whoa, skipping that. So again, this is almost like when we talk about like the giant talk about the water cycle. How is wind formed? Not a shocker here. It starts with the sun's radiation. We said this at the beginning of the year. The sun is the main source of energy for so many things. It's the catalyst for an uncounted amount of things on Earth, but wind formation is another. The sun's heat is absorbed differently by the world around us. You have cloud cover, mountains, valleys, lots of water like oceans. You have giant deserts. You have rainforests. And because of all of these different varying features, the Earth is heated unevenly. When you have that uneven heating of the Earth, you are then going to have those updrafts and downdrafts that we just talked about. When you have those updrafts and downdrafts, you start to form these areas of higher pressure and these areas of lower pressure. And when that happens, that's again how wind is formed. We will talk about some of the global wind patterns, and we are coming up on one of my absolute favorite lessons to teach in the entire year. We're going to watch a video, and we're going to do a discovery SOS strategy. We're going to draw a picture and put all of our notes inside of the picture. And it is an extremely interesting, very, very unique story to learn about. And it all deals with the global wind patterns. And we can see some of those listed over here, the trade winds, the westerlies, probably the most important for us because it's these prevailing westerlies that move all the weather from California all the way across the United States. Obviously, the jet stream can interact with that as well. But that's not to take away from the trade winds. That's not to take away from these easterlies. And then right around here, they don't have it listed. There's an area called the doldrums. And that's an area where the wind doesn't really blow hardly at all because when you're right on the equator, you really don't have a whole lot of uneven heating. It's all hot. And when you don't have a lot of uneven heating, you have very, very, very little winds. And we're going to get to watch in the video what it's like to be in the doldrums. And I just want you to imagine what it would be like in the doldrums if you were the captain of a sailboat. You would really have to kind of figure out what's going on. Now, I'm not saying there is zero wind. That's not possible. But there just aren't as strong of winds as you see in some of these other places like the trade winds, the westerlies, and the easterlies. And I think I am going to stop here, which will allow us some other time to work on some of the other things that we have to do in class today. And we will pick back up with these global wind patterns in our next lesson, which will probably be Friday.